Good morning, Internet. I am Matt Buyak, and in this video, we're going to be playing some poker. And by that, I mean we're actually going to be teaching a computer how to play some poker as part of our solution to Problem 54 from the Project Euler Problem Archive. This problem gives us a file with 1,000 poker hands played between two players, and we have to determine the winner of each hand. Now, there's nothing to stop us from just going through this file line by line and determining the winner ourselves, but then the video would be like 2 hours long, it would be very boring, and we would probably get the answer wrong anyway. So we're going to write a program to do the work for us. Now, don't worry if you don't know anything about poker and have no familiarity whatsoever with playing cards. I'm going to tell you everything you need to understand in order to be able to solve this problem. So the first thing is that each poker hand is 5 cards chosen from a deck of 52. Each card has a suit and a rank. For example, on this card, the suit is clubs, represented by the clover-shaped icon. And the rank is queen, abbreviated by the letter Q. The ranks include numbers 2 through 10, with a 2 being the lowest rank, as well as higher ranks jack, queen, king, and ace, with ace being the highest rank. The suits are diamonds, hearts, clubs, and spades. Unlike ranks, suits have no particular order or priority, at least not in poker. 4 different suits of 13 ranks each make a total of 52 cards. Unfortunately, there is no simple rule for determining the value of a poker hand. Instead, there are 9 different types of hand, with hands of better type winning over hands of worse type. In order, from worst to best, the hand types are high card, 1 pair, 2 pair, 3 of a kind, straight, flush, full house, 4 of a kind, and straight flush. The top hand pictured here isn't just any straight flush, but the highest possible straight flush, called a royal flush. Note that the problem statement on Project Euler lists the royal flush as a separate 10th category of hand. Now, different types of hands are formed in different ways, but in general, having more cards of the same rank will make your hand more valuable. Let's consider each of the different hand types in order, starting with the lowest. If all the cards in your hand have different ranks, it's probably a high card hand, which is the lowest type. It gets its name from the fact that if 2 players both have a high card hand, then the high card determines the winner. Be warned, there are actually 2 ways in which a hand with all different ranks can be one of the most valuable rather than a high card hand, but we'll get to that in just a moment. The next lowest hand is 1 pair, which has exactly 2 cards of matching rank. And if 2 different ranks are duplicated, we have a 2 pair hand, which comes just after 1 pair. As you might guess, the hand above that is 3 of a kind, which has 3 cards of all the same rank. Now we come to the first example of a hand which has all different ranks, but is actually quite good. This is the straight, where the ranks form a run of 5 consecutive values. In this case, that's 3, 4, 5, 6, and 7. This is the other hand that has all different ranks, but is not considered a high card hand. This is a flush, where all 5 cards have the same suit. Note that this is the only type of hand where the suit of the card is relevant. All the other hand types depend only on the rank. Now we're getting into some seriously strong hands. Depending on exactly which rule set you're using, you might almost never see these last 3 hand types in an actual poker game. This is a full house, which combines a pair with a 3 of a kind. Out of 700 random poker hands, you would expect to see just 1 full house. And if you manage to get all 4 copies of a particular rank in the same hand, that's a 4 of a kind, which is the second highest type of hand. And last, if you manage to put together both a straight and a flush at the same time, you have the best kind of hand in poker, the straight flush. And the very best of the best, if you manage to include the full royal family in a straight flush, is the infamous royal flush. As I mentioned earlier, though Project Euler lists this as a separate type of hand, we don't actually need to consider it separately, since it's really just the best straight flush. This all may sound very straightforward, but now we have to consider the case where two different players have the same type of hand. As you might expect, in this case, having higher ranked cards is good, and having more of the same high ranked card is even better. Let's start by considering how tie breaks work with a high card hand. First, let's sort each hand in descending order. Now we compare cards from left to right. In this case, the near player's king beats the far player's 9, so the near player has the better hand. As I mentioned earlier, this is where the name of the hand, high card, comes from. Now let's look at a slightly more complicated case. As before, we've sorted the hands in descending order. But this time, when the players compare their high cards, we see that they match. No matter, we'll move on to the second highest cards. The queens also match, so we have to look at the third highest cards. Finally, the near player's jack defeats the far player's 5, and so the near player is victorious. Note that in an actual poker game, you wouldn't rearrange and reorder the cards in this way. I'm only doing so here as an aid for understanding the rules. Now consider this hand. As before, we've sorted the cards in descending order, but now we see that each player has some duplicates. Organizing the duplicates into stacks, we can see that each player has one pair. To determine how to break the tie, we sort the cards again, but this time by stack size. As before, we compare the stacks in order, starting from the left. We see that the far player has a pair of queens as compared to the near player's pair of jacks, so the far player has the better hand. Here we see almost the same two hands, except now both players have a pair of queens. To break the tie, we continue comparing the stacks from left to right until we find two that don't have the same rank. The near player has an ace compared to the far player's king, so this time the near player wins. I think you're probably getting the idea at this point, but let's look at just a few more examples. Here we see each player has two pair, and we sorted the stacks by size and also by rank. Note that it's important that we sort the stacks of cards as well as the individual cards, otherwise we'll get the wrong answer. Here, because we've sorted our stacks correctly, we compare the queens first and see that the tie is unresolved. Then we compare the near player's pair of jacks against the far player's pair of 10s and see that the near player is again victorious. Note that in the unlikely event that both pairs match, we then compare the final remaining card to determine the winner. In this example, the near player's 9 beats the far player's 4. One final corner case, which is literally 1 in a million, occurs if both players have a full house. Well, technically it's more like 3 in a million, but in any case, here we see why it's important not just to separate the stacks from the single cards, but to actually sort the stacks by size. In this case, the far player's 3 queens triumph over the near player's 3 jacks. Note that the fact that the near player has 2 aces doesn't matter at all. They might as well be a pair of 2s for all the difference it makes. Note that I didn't go over exactly how tie breaks work for all 9 possible hand types, but the others are resolved in a similar fashion. First sort by rank, then group duplicate ranks together, then sort the stacks in descending order, first by size and then by rank, and lastly, compare in order from left to right. In the examples above, the far player's straight wins with a 7 over a 6, the near player's flush wins with a king over a jack, and the near player's 4 of a kind wins with 4 queens over 4 10s. So now that we understand how to evaluate poker hands, we need to figure out how to turn this into code. And the structure of our solution is going to be pretty straightforward. We're going to read in each of 1,000 pairs of poker hands. The problem statement tells us that that's how many there are in the file. And for each hand, we're going to call some kind of evaluation function to determine how good the hand is. And then for each pair, we'll compare the results to see whether player 1 wins or they don't. And then at the end, we'll print out the total number of hands won by player 1. So ideally, our evaluation function would just return a single integer. That would make it really easy to compare between two hands. And in theory, that is possible. There are only a finite number of poker hands. You could give each one a score such that one hand will have a better score than another if and only if it's actually a better hand. But doing so gets into the field of combinatorics and would probably make this video twice as long. And so we're going to have to instead return some more complicated object from our evaluation function. And in particular, we're going to return a pair. And the first element of the pair is going to be the hand type. And the second is going to be some kind of tie-break information that we'll have to define. And the way comparison between pairs works is that it first compares the first element, and if they are different, then it uses the result of that comparison. If they are the same, it moves on to compare the second element from each pair and uses that as the result of the comparison. And that's exactly the behavior that we want. We want to compare hand types first, and if the hand types are the same, only then move on to comparing the tie-break information. So since we're going to have to be calculating that tie-break information anyway, I think it's important to note that not only is that information useful for determining the winner in the case of a tie, it's actually good for differentiating between hands more generally. In fact, the only hands that can't be differentiated based just on the tie-break information are straights and flushes, because they work a little bit differently. And so determining this tie-break information is really going to be the core of our evaluation function. As I was describing just a few minutes ago, the idea is that we're going to take our cards, sort them by rank, determine any duplicates, that is, organize them into stacks, and then sort the stacks based on size and rank. And that will be our tie-break information. Now, as I just said, somewhere in there we're also going to need to determine if we have flushes or straights. And in fact, for the flush, it's good to do that right at the start, because then we can get rid of the suit information. That's the only time we need that information. And then for the straight, it's good to do that right after we've sorted our cards by rank, because it's really easy to check if we have a straight when our cards are sorted. So I think that gives us enough information to get started. So let's get into it. So as usual, I'll copy our template directory to make our problem directory. Copy our list of poker hands into our problem directory. Enter our problem directory and open our main.cpp. Now I'm going to tackle this problem in sort of a bottom-up fashion. That is, we'll start by defining some basic types that will be useful, then implementing our evaluation function, and then ending up by implementing our main function. So the first thing we're going to need is a way of describing the type of our hands, and we'll use that, do that using an enum class. So enum class hand type. But one thing that may be a bit surprising is the list of hand types that I'm going to define. In particular, I'm going to define low hand, straight, flush, high hand, and straight flush. As I mentioned, the tie-break information can actually be used to differentiate between all hands which aren't straights or flushes. And so we don't actually have to have separate hand types for each of the low hands and for the two high hands. That is for four of a kind and full house. We can just sort of lump those together as a single hand type. Okay, so the other key thing that we're going to need in returning from our evaluation function is that tie break information. And so let's look at how we might define that. We'll call this tie break T. It's going to be a structure. And we're going to need to have some number of stacks of cards. And for each stack, we'll need to know the size and the rank. And there can be up to 5 stacks. And so I'm going to use an array to hold our stacks. So we'll say std array. And let's just call this card stack T. There's going to be up to 5 of them. And we'll call that stacks. And let's include array. Okay. And now we'll need to also define this card stack T. And we can really just use another pair for that. We don't need to define a separate type. So I'll just say using card stack T is just going to be a pair of integers. Now, one nice thing about using a pair again like this is that it has the same behavior I was describing earlier, where it's going to compare the first element first and then the next element only if the first element matches. And so we can use the first element as the size and the second element as the rank, and that will give us exactly the behavior that we want. So let's maybe make a note. First equals size, second equals rank. Okay. Now we're going to need to have a function to let us compare 2 different tie breaks. The mechanism I was describing earlier, where we're comparing the pair that we returned from our evaluation function, only works if a comparison is defined for both of these elements. And so we'll need to define comparison for our tie break. So let's say bool operator less than is going to take a const tie break T reference TB const. And we need to be careful how we do this comparison. Let's start by assuming that these stacks are sorted. So we'll say assume stacks are sorted. Okay. Well, we need to first compare the sizes of each stacks before we consider the ranks. That way, we'll correctly differentiate between the various low hand types and the high hand types. So let's say for int I equals 0, I less than 5, increment I. Okay. We'll want to check to see if there's a difference between the size of 2 different stacks in the 2 different tie breaks. So let's say int size is going to be equal to stacks I dot first. Remember, we made a note for ourselves up here that size is going to be the first element of the pair. And then int tb size is tb.stacks I.first. Okay, so now we'll say if size is less than or is not equal to tb size, return size less than tb size. That is, we're only going to compare these if they are different. If they are the same, however, after we've gone over all of the stacks, then we need to compare the ranks. But we can do this just by saying return stacks less than tb.stacks. Okay, so let's just double check this. The idea is that we're going to first iterate over all of the stacks, and if they're different at all, then the result of this comparison is just going to be the comparison between those two stacks. If we iterate over all the stacks and they're all the same size, or each pairwise comparison, they're the same size, then the difference or the comparison is going to depend on comparing the ranks. But we can compare the ranks just by doing a comparison between the arrays. This works similarly to the comparison between pairs, where it will compare the first two elements, then the next two, then the next two, etc. And you might wonder why we only use this after comparing stack sizes instead of just doing this right from the start. And the problem is that would fail in the case where, for example, one player has two pair and the other player has one pair, but the player with one pair has a high pair of say aces, and the player with two pair only has a high pair of kings. It would compare the size of the first stack, which would be 2, and then it would see that one player has aces versus the other player's kings, and the player with one pair would be declared the winner, which is not what we want. So we have to compare stack size first and then compare ranks. Okay, this should be what we want. All right, so now let's get to writing our evaluation function. So let's do using result t is going to be a pair consisting of a hand type and a tie break. Okay, and then our evaluation function is going to return a result t. We'll say evaluate hand. And the hand is going to come in the form of strings. Once we've read the hand from our input file, we're just going to have a string for each card. So let's maybe actually think about how we might define a hand. So we'll say a hand t equals an array of strings, and there's going to be 5 of them. I don't think I've included string yet, so let's be sure to do that. Okay, so this is going to take a constant hand t reference hand. Okay. And the first thing that we're going to need to do is to convert this hand that is in string form into something more useful. But actually, as I stated in the intro to this section, we want to check for a flush first. So we need some way of getting the suit out of our hand here. And so let's do that. We'll say char suit from str. So this is going to take a constant string reference card, and we'll say return. Actually, let's check just to make sure we get it right. Yes, so the rank is first, the suit is second. And so we'll say return card 1. We don't need to have a special enumerated value or anything like that for the suit, because we just need some way of distinguishing between different, whether the suit is the same or different, and storing them as a character is perfectly fine for that. Okay, so we want to find out if we have a flush or not. So we'll say bool flush equals true. And then we'll say character suit is going to be suit from str. And we want to say hand 0. Yes, hands, that's going to be the first card in the hand. So we're getting the suit of the first card. And then we'll say for, let's see, const std string reference card in hand. We'll say if suit from str card is not equal to suit, then we'll say flush is equal to false and break. So we're going to check each card in our hand and see if it has the same suit as the first card. And if any of them have a different suit, then we say, no, we don't have a flush. Okay, so now we want to organize our hand just by rank. We don't care about the suit information anymore, and we want to be able to sort our ranks. And so let's pull in vector here. Go up here and say include vector, and we'll say std vector of integers, and there's going to be 5 of them, and we'll say ranks. Now we need some way of getting the rank of a card from the string version of the card, and so let's do that. We'll say int suit, or not suit, we already did suit, rank from card, from str. And that's going to be a string. And we'll say char rank is going to be card 0. But now we need to turn it from a character into an actual rank, because we want to be able to easily compare whether a rank is higher or lower than another. And so we can't just leave it as a character, especially since we have these strange ranks like queen and king and ace, which aren't represented by numbers. Okay, so let's say switch. I don't know that I've used a switch statement in any of my problems recently. Okay, so first of all, if we have an ace, let's start with an ace. We'll start at the top. I'm doing the syntax all wrong here. Then we can just say return 14. Okay, why 14? Well, if obviously a 10 is a 10, then Jack would count as 11, Queen would count as 12, King would count as 13, and Ace counts as 14. So we say return 14. Case King is going to be return 13. Case Queen is going to be return 12. Case Jack is going to be return 11. And case T is for 10 is going to be return 10. Okay. And so now we need to handle the the remaining cases, so that's going to be default, we'll say if rank is less than 2 or rank is greater than 9, then something has gone horribly wrong. And so we probably want to say printf unknown rank in hand. And then at that point, we'll just abort. That is, just kill the program. Something has gone horribly wrong. Just end immediately. Okay, but if we have a character in the range from 2 to 9 inclusive, then we'll want to say return rank minus the character 0. Okay, so that should get us our rank from string. So let's now go and stick all of our ranks into this vector here. So we'll say actually we can build up our ranks at the same time as we're doing our flush detection if we're careful about it. So let's actually move this up here. Okay. And then as we're going through our hands, we'll say ranks.pushback rank from str card. But we have to be careful not to break here, because we still want to finish adding our ranks to our vector of ranks, even if we find out that we don't have a flush. Okay, so now we have our ranks. Let's sort them. We'll say std sort ranks.rbegin, ranks.rend. And I'm using this rbegin and rend because I want to sort them in descending order rather than ascending order. This just uses the reverse iterator and the reverse end iterator over here rather than the usual begin and end iterators. We'll also have to include algorithms so we can use this sort. So let's do that. Okay. So we have our ranks. Now we want to build up our stacks. So let's say, actually, let's go back up here to the top and say result t ret. And you'll recall that that's just the alias that we added for this pair, which has both the hand type and the tie break. Okay. And we're going to make a useful reference here. Let's say, what actually is the type of our, if we go back up to our tiebreak T, yeah, we have this array of card stacks here. And so let's say a reference is going to be equal to ret.second.stacks. That is the second element of our return value is going to be the tiebreak information, and we want to be accessing the stacks. Okay. So now we need to organize our ranks into these stacks. And so let's say int numstacks, and we'll say for actually, let's say yeah, int rank is equal to ranks 0. And we want to keep track of the size of the current stack, so we'll say count is also going to start at 0. And then we'll say for int r in ranks, we're going to see if the current rank matches the previous rank, or if we have to start a new stack. So we'll say if r is equal to rank, then we're just going to increment the size of the current stack. If it's different, then we need to add that stack to our stacks and start a new stack. So we'll say, also I need to initialize this to 0. Okay, so we'll say stacks 0 is going to be, and I believe this is a pair. Let me just, card stack T. Where did I? Yes, card stack T is just a pair of integers. Okay, and so we can say stacks 0, stacks num stacks is just going to be equal to make pair, and we want the size first, so we'll say count and rank. And then we want to increment num stacks and update the value of rank and count. So we'll say rank is now equal to r and count is equal to 1. We've started our new stack. Okay. Once we get to the end of the loop, we will still have one stack that's in progress that we have to add to our stacks. So we'll say stacks num stacks equals make pair count and rank. Okay, so we should now have our stacks. So let's sort them. Should be able to just do sort stacks.rbegin, stacks.rend. As before, we want to sort in descending order, so the most valuable stacks appear at the front. Okay, so now we have our stacks in order, and I'm realizing that we've actually missed a step. We need to, at some point, determine if we have a straight or not. So let's look at what the best moment to do that would be, and I think it would be right here, because we've just sorted our ranks in descending order. It would be very easy to check if we have a straight. So let's say equals true. And we'll say for int r in, oh, actually we need to do a little bit of a trick here. Let me actually, I'm going to reuse this name, so I'm going to define this up here. Int rank is going to be equal to ranks 0 plus 1. And I'll explain why that is in just a moment. So we'll say int r is going to be a member of ranks. And then we'll say if r is not equal to rank minus 1, then we'll say straight is equal to false and break. Okay, now maybe you can tell why I initialized this the way that I did. By setting rank to just one more than the rank of the first card, when it does this check on the first, for the first element, it will see that it is indeed equal to rank minus 1. Then for each of the subsequent cards, it's just checking whether the, once I actually update rank equals r, now it will check to see if the current rank is one less than the previous rank. Okay, so that should identify whether we have a straight or not. Okay, so then we know if we have a flush, we know if we have a straight, we have organized our stacks, so now we just need to figure out what our hand type is. So let's make some logic for that down here. Recall that the hand type is going to be the first. It's going to be this ret.first item. Okay, so let's say first if we have a flush, then we want to check if we have a straight, and if we have both, we have a straight flush. So we'll say ret.first is equal to hand type straight flush. Okay. If we have a flush but we do not have a straight, then we just have a flush. So we'll say first is equal to hand type flush. If we don't have a flush, we might still have a straight. So we need to check that. If straight, then ret.first is equal to hand type straight. Otherwise, we need to determine whether we have a low hand or a high hand. And the easiest way to check whether we have a high hand is to check the size of the third stack. Because there are only two ways that we could have only two stacks. And that would be if we have a full house, in which case we have stacks of size 3 and 2, or we have 4 of a kind with stacks of size 4 and 1. Any other hand is going to have at least 3 stacks. And so we'll say else if stacks 2 dot, let's see, the size is going to be the first element there. I believe this is also a pair. Let's see, we'll say card. I know I already checked this once. Card stack T, yes, is a pair of integers. And the second one is the rank, and the first one is the size. Okay, so we are checking the first one, which is the size. So if that is 0, that means we only have 2 stacks, and we must have a high hand. So we'll say ret.first equals hand type high hand. Else ret.first equals hand type low hand. Okay, I think that's all we need on that front. And now we should be able to say return ret. Alrighty. So now we just need to actually read in our hand and evaluate each pair. Okay, so let's see here. Let me just remind myself. Yes, we've defined this hand T as an array of 5 strings. So let's go down here, and we're going to say hand T, or actually std pair hand T. Actually, let's not make it a pair. Let's make it just a regular C-style array. We'll say hand T, hands, and there's going to be 2 of them. Okay? So then we want to iterate over 1,000 pairs of hands. So we'll say I is 0, I is less than 1,000, increment I. And then for each pair of hands, we want to read in and evaluate each hand. And so we'll say for, let's see, int j is equal to 2. J is, no, excuse me, my mind is wandering, excuse me. Okay, so we're going to iterate over the 2 hands. And so then we need to, within that, read each of the 5 cards. So we'll say for int k is 0, k is less than 5, increment k. Okay. So then we'll just say stdcin hands j k. Yes, because each hand should be an array of 5 strings, and so this is just reading in the string that corresponds to that card. And we will need to include IOStream. Okay. If you're not familiar with what I'm doing here, basically we're just going to pipe the input file excuse me, into our program and read it through standard in right here. And so this is going to get each of our 2 hands. Okay, so once we've read in our pair of hands, we need to get the evaluation for each. So we'll say result t. First hand is going to be, let's see, evaluate hand, hands 0. And result t second hand is going to be evaluate hands 1. Okay, and then we're going to need a counter to keep track of our solution, starting at 0. And so we've got our 2 results, and so we should just be able to say if second hand is less than first hand plus plus solution. And then after we've evaluated all of our pairs of hands, printf solution equals %d. Okay, so let's give it a shot. So we'll go back to our shell, and we will make. It's a little unhappy. Let's see what's going on there. This many problems, I almost wonder if I didn't include something. Let's see. Has no member named stack. Oh yes, stacks is what I intended. Okay. What else do we have here? Type value mismatch in argument 2. Oh, I declared our vector as if it were an array. We don't need that, so let's go to vector. This is just a vector of integers. Okay. Let's see. It says that ranks is non-class type int. Well, that shouldn't be correct. Expect that will be fixed once we resolve that. Let me just try rebuilding and see if that resolves the rest of the issues. Almost. Expected primary expression before char. Let me take a look. Okay. Oh, we're not declaring rank. We're just switching on the value of rank. Okay, we have that. Let's do cat po54 poker.txt and pipe into solver. So this will allow us to read the contents of that file from standard in. Okay, we have solution equals 376. So let's go back to the archive. And as usual, I will need to sign in. And now we'll go back to our problem. And we have a momentous occasion. This is the lowest numbered Project Euler problem that I have never actually solved. It's not that, as you see, it's particularly difficult. I just chose to skip over it back 10 years or so ago when I was first going through these problems. So we get to find out together, did we actually get it right or not? 376, check. And you see that that is in fact the correct answer. So thank you very much for joining me in this video. In the next video, we'll be tackling problem number 60.